Hello, I'm Keith Fukuhara. I'm the Chief Technology Officer for ZeroNines Technology, Inc. What I'm going to show you here is our always available architecture today. What I have in front of me is a user machine. I have a switch. I have Node 1, Application Server 1, Node 2, Application Server 2. At the core of our technology, we have the switch software, the node software, in this case Node 1 and Node 2. When a user enters our system, the switch forks that session off to both Node 1, Node 2 in parallel. Each node responds back to the switch, and then the switch decides which response to send back to the user request. Looking at the framework of our core technology, I'm going to highlight three modules that we have. The Guaranteed Message Server guarantees that all communications between switch and node will be processed. We timestamp and sequence each one of those messages so that they are processed in order at all the locations. Our journal server is a recording device. It basically takes all the communication between switch and nodes and writes it down to disk. Our synchronizer works like a DVR. We use a synchronizer to take the transactions off the journal and play them back. So in the event that a site was down, I can use the journal and the synchronizer to rebuild a site or recover from a disaster. The last portion that I will highlight is a protocol proxy. Within the protocol proxy modules, we have protocol adapters that allow users to communicate to various applications. In the case of the demonstrations today, we will show you email protocols, POP3 and SMTP, as well as web services modules, HTTP and or HTTPS. To get started, what I will do is on my computer here, I'll bring up a electronic mail interface. One of the things that you do with mail is go out there and retrieve your mail from a mail server. In this case, my mail servers are on Node 1 and Node 2. So what I'm going to quickly do is do my send-receive process here. I'm receiving my mail. What it does right now is it goes out there, it authorizes with the servers, and you see the transactions happening on both screens simultaneously. So what our system does is when I say fetch my mail, it makes a connection to the switch. The switch then forks the process off so that it's making the same request to Node 1 as well as Node 2. For purposes of showing how always available works, I'm actually going to just break the connection to Node 1. I basically take my network connection. Node 1 right now is down. As I hit send receive once more, my system's going out there connecting to the switch. It's trying to communicate with Node 1 and Node 2. But since Node 1 is down, nothing has occurred on screen. All my mail checking came off of Node 2. The minute that I start to have my system come back from failure, in this case, my network gets reattached or reconnected. When Node 1 recovers from whatever disaster it had, it will automatically say, did I miss any transactions, and automatically replay them without any intervention. This is how we maintain redundancy between Node 1 and the Node 2 applications. The other portion of electronic mail is not just being able to pull my mail off the server, but actually having someone send me messages. In this case, I've created a quick demonstration that has about a 1.2 meg file attached to it. Once I hit send, that message automatically will start to go into the switch. Process gets down to where the message is sent to both mailboxes in Node 1 and Node 2. Independently, I could have one of my boxes, again, break a connection, and that message will still get down to one of my servers. When the system recovers, again, that message will get completed delivery at the node that was broken. That is all part of the guaranteed messaging, the journal, and the synchronizer working together. At this point now, I'm going to go back and actually retrieve that message, and you'll start to see a lot of the information flow on screen. And that just really shows that, hey, that last message I sent myself got to all the machines. We've also created a protocol adapter for web services, HTTP and HTTPS. In this case, I've got my Mozilla Firefox web browser here. And I'm going to click onto a shortcut that I have for our always available travel website that are running on the application servers. When I open up my website, the traffic is flowing through all the nodes in parallel. And likewise, just like we did with the electronic mail protocol, if I were to break a connection, I'll still be able to be serviced by my second node. And eventually, when Node 1 wakes up, we'll catch up to where Node 2 is. Now that I've shown you always available services for the web, We can apply this to e-commerce, let's say even a real travel site, to where you were in that last minute with your wife booking that vacation to Hawaii or Bermuda. Always available services at the web will guarantee that that transaction will be processed. For more information, please visit our website, ZeroNines.com.